All right, parts of similar triangles. Page 501. There's 3 theorems on page 501. All 3 theorems start with if 2 triangles are similar, the lengths of corresponding. And then they all end with are proportional to the lengths of corresponding sides. So we're going to combine all 3 of those theorems. So you don't have to write as much. So they all start with if 2 triangles are similar, the length of corresponding we're going to go altitudes angle bisectors and medians are proportional to the lengths of corresponding sides. If 2 triangles are similar, the length of corresponding altitudes, angle bisectors, and medians are proportional to the lengths of corresponding sides. So let's do a review of altitude. Altitude of a triangle. It goes from a vertex to the opposite side and it intersects at 90 degrees. Altitude of a triangle is the same as the height of a triangle. Angle bisector. That's a tough one to remember. Right? The angle bisector of a triangle. That's hard to remember what exactly that is. So what you need to remember is what it's called. It bisects an angle of the triangle. Okay? So if you get this picture and these angles are congruent, well then this red piece, it bisected that angle, didn't it? So what's it called?
An angle bisector.
Good, class. Very good. And then a median. And when you see or hear the word median, what do you think? Yeah, the thing that goes down the middle of the road. I don't drive on it. Well, you're not old enough to drive anyway. So median goes from a vertex to the middle of the opposite side. So it looks like this. A segment that goes from a vertex to the middle. How do you know it's the middle? Because these tick marks say that this point is the same distance from both vertices. So it's a median. Alright? Everybody okay with that? High dollar vocabulary right there. So take a look at page 502, example number 1. You got a triangle on the left. It's got that segment down the middle, and you're told those angles are the same. So that is a, what is that segment called? Good, an angle bisector. Just went over that, right? And then you've got a triangle on the right, and it's got something, a segment that bisects an angle. So that segment is called the angle bisector. Good. And we've got an 8 and we got a 12. Solve for x. Find the value of x. And you're told that the triangles are similar. So you just wrote down a rule, didn't you? You just wrote down a rule that said that if the triangles are similar, then the angle bisectors, what do? The lengths of the corresponding angle bisectors are proportional to the lengths of the corresponding sides. So if you write a ratio of angle bisector over side, which is x over 15, that's going to be equal to angle bisector over side, which is 8 over 12. Good. Crisscross multiply, so 12x equals 15 times 8, 120. Divide both sides by 12. X equals 10. Any questions there? Anybody? Altitudes, medians, and angle bisectors all have the same rule. The length of each is proportional to the corresponding sides in similar triangles. Okay? If you look at the bottom right of page 502, you've got a triangle there on the left. Or go ahead and set it up and do it while I'm drawing it. You've got an X here and a 13.5. And then in your other triangle, what's the segment running through those triangles? What's it called? A median. Because it splits the opposite side in half, doesn't it? 3 and a 9. Bottom right of page 502. Now, just take a look at this for a second. This is kind of a technicality, but I'll need you to see it. If you write your proportion for the triangle on the left, all right, I'm going to call it x over 13.5. That's the segment created over the median. Agreed? Equal to. Now, do you see where this x is right next to the two-sided or the two arc marks? Okay. But down here, you don't have anything next to the two arc marks, do you? But what is that piece equal to?
3.
It's equal to 3 because they're congruent. Okay, so if we went piece created over median, we got to go piece created over median. All right? So we got 9x equals 40.5. Divide by 9. X equals 4.5. Everybody all right with that? All right, turn the page. We got to get one more rule in your notes. An angle bisector in a triangle. Separates the opposite sides. Into two segments. That are proportional to the other sides, to the other two sides, to the other two sides. Now in this case, we're only talking about one triangle, an angle bisector in a triangle. So if you draw a triangle, and you put an angle bisector in there, angle bisector. So these angles are congruent to each other. Let's label this up. Here's what you're going to remember about this situation. Angle bisector. What it says is that this angle bisector creates these two pieces, doesn't it? Okay? These two pieces that were created are proportional to the other two sides of the triangle. Okay? So BC over CD. This piece right here over the side that it's next to is going to be equal to what? Good, AB over AD. Alright, this piece, the other piece it created over its side. Everybody alright with that? So if we put some lengths in there, we'll put in a... They don't even... Yeah, they do. Alright, let's go with an X and a 6. Call that X, call that 6. And we're going to call this 14. And this piece is given. And it's 18. Oh, this is going to be fun. So, what's the proportion going to be?
X over 6.
X over 6 equals? Well, these aren't equal to each other. What's AB equal to? Well, if this is 18, how would you find A to B? What if X was 2? What would A to B be? 16. What if X was 4? What if X was 8? What are you doing every time? Aren't you doing 18 minus X? So isn't AB equal to 18 minus X over its corresponding side, which is 14? So now you got a little more algebra to do, right?
Yeah.
Alright, so crisscross multiply, which means distributive property. So your X times 14 is 14X equals 6 times 18 minus X. What's 6 times 18? 108 minus 6X. Add 6X. So 20X equals 108 and divide by 20. 5.4. And what I've noticed about this textbook is that once you start to see a concept like this, where you have to create an expression for a side length, all right, this side AB right here, or this segment AB, is equal to 18 minus whatever X is. It's going to keep showing up. in angles, complementary angles, where you may have to go 90 minus x equals the other angle. Supplementary angles, where you're going to have to, they're going to give you, you may get a picture that looks like this and you're told that this is x. Alright? And you need to come up with an expression for this angle. In this picture, wouldn't this be 180 minus x? Alright? You're going to start seeing this, where this is 90 degrees and this is here and this might be m. You're going to need an expression for the other angle. Alright? In that case, it would be 90 minus m. You're going to have to start creating the expressions for a missing piece. Okay? Alright. So let me give you some practice for today. How's that sound? Good. Page 505. Let's do 6 through 16. Be sure you're showing all your work. When I say show all work, I don't mean draw the triangle and then write an answer and circle it. I'm not concerned about the drawing of the triangle. I want to see your proportion. I want to see your crisscross multiplication. And then I want to see how you solved for the missing piece. Okay? That's what I mean by show all work. No show work, no get credit. Capiche?